Welcome to this video on operational concepts in computer systems. Every computer operates through a series of well-defined processes to execute tasks. In this video, we will dive into the core concepts that define how a computer operates and processes information. Let us discuss about the basic function of computer. To execute a task using a program, a computer's main job is to follow instructions to complete tasks. These instructions come from a program like an app or software you use. For example, when you open a game on your phone, the program tells the computer what to do, like showing the screen, controlling movements, etc. Programs are stored in memory. A program is a list of step-by-step instructions for the computer. These instructions are kept in the computer's memory like a short-term memory. For example, when you play a video or write a document, the instructions to run the video player or word processor are stored in memory so the computer can easily follow them. This diagram shows how the processor communicates with the memory and input-output devices in the system bus. Inside the processor, we have key components. The MAR or memory address register holds the address of the memory location we want to access. The PC or program counter keeps the track of the next instruction to execute. The IR instruction register stores the current instruction being processed. The MDR or memory data register temporarily holds the data being transferred to or from the memory. Alongside, we have general purpose registers labeled R0 to Rn-1, which store data and intermediate results. The control unit directs the flow of data and coordinates operations, while the ALU or arithmetic logic unit performs calculation and logical comparisons. General purpose registers are used for holding data intermediate results of operations. They are also known as scratch pad registers. All these components work together through the system bus to move instruction and data between memory, input-out devices, and the processors, enabling the execution of the programs. This diagram shows the basic operational concepts of how the processor communicates with memory and input-output devices and how it fetches and executes instructions. The process starts with program counter, which holds the address of the next instruction to be executed. The address is sent to the memory address register. The processor then sends a request to the system bus to the memory. The memory responds by placing the instruction at that address into the memory data register. From the memory data register, the instruction is transferred to the instruction register, where it is decoded by the control unit. Once decoded, the processor moves the execution phase. If the instruction involves data from memory, the MAR and MTR work again to fetch the data. If it is an arithmetic or logic operation, the data is sent to arithmetic and logic unit where the operation is performed. Results are stored in general purpose registers such as R0, R1 and so on. or written back to the memory if needed. Finally, the program counter is updated to point to the next instruction and the cycle repeats. This fetch, decode, execute cycle happens millions or even billions of times per second in modern processors, forming the backbone of all computer operations. Let us look at some typical assembly language instructions and understand how they execute inside the processor. The first instruction is load R2, LOC. Here, the CPU fetches the instruction from the memory into the instruction register. The control unit decodes it and realizes it needs to load data from memory location LOC into register R2. The address LOC is placed into the memory address register and the memory responds by placing the data into the memory data register. That data is then moved into the register R2. The second instruction is add R4, R2, R3. Again, the instruction is fetched into the instruction register and decoded. This tells the arithmetic logic unit to take the contents of the register R2 and R3, add them and store the result in R4. The control unit sends the necessary signals to the ALU, which performs the addition and updates R4. The third instruction is store R4, LOC. The CPU fetches and decodes the instruction, then moves the content of R4 into memory data register. The destination address LOC is placed into the MAR and the system bus transfer the data from the memory data register to memory. Each of these examples follows the same core process: fetch, decode, execute, and store results. The heartbeat of the CPU.